Hi. The Unit 2 retest was challenging. Even though it was a retest, there's just a lot going on this test. You've got decimals, fractions, negatives, and students still are struggling at times. Many students did well, but there are others that still need to put in some more support to build their knowledge with these topics, with these rational numbers. So I'm going to do this retest as a think aloud so that students can access it at their own pace and see things again if they need to, slow things down, speed through things that they don't need to know, and I am hopeful that they will be able to use this tool to help make sure that they are prepared for future tests on the same topic. So we're going to start off with the first direction. Write the rational number as a decimal. The fraction bar for both of these means to divide. But the first thing that I did announce to the students, and they all were aware of this, is that you want to notice that both of these first numbers 1 and 2 are negatives. So I would go right over to the answer column and immediately put my negative sign just so I didn't forget that. Now the fraction bar here means that you're going to divide. Top number goes under. Add a decimal and a 0. Bring the decimal straight up. And you've got 9 into 20 is going to be 2. And it's always going to continue to be, when you add another 0, 9 into 20. So it's going to be 2 going on and on. So that means it's a 2 repeating. So we put the repeater bar above it. So the answer here is going to be 0.2 with the repeating bar. Next, number 2 already had a -3 as the whole number part. We want to keep the -3 and just divide the 11 by 20. So we're going to add a decimal and a 0 again. Bring the decimal straight up and normal divide. 20 does not go into 1, nor does it go into 11, but it will go into 110 5 times. With 10 remaining, that's less than 20, so it's okay for the next number to come down. 20 into 100 is going to be 5, and then there will be nothing left. This is a terminating decimal, different than number 1, which is a repeating decimal. So I'm going to take this 0.55 part and add it behind the -3, and that's the answer for number 2. Next direction, write the decimal as a fraction or a mixed number in simplest form. Well, the 4 can stay, and you've got 2 decimal places, so you're going to put it over 100 because this is said 4 and 22 hundredths. It ends up in the hundredths column, which is the same as this, 4 and 22 hundredths. And then we need to put it down in simplest form, so I can use factor bubbles, and I can divide these both by 2. This becomes an 11, and this becomes a 50. So our final answer is 4 and 11/50ths. Number 4, again, watch out for the negative, so I would put that first. There's 2 decimal places, so it's going to be 45 over 100, and then you can divide by using factor bubbles. You also can use the giant 1, which is the property of 1, where you take and divide by the greatest common factor. For this is going to be 5, and they call it giant 1 because you usually put it inside a 1. And you can see 45 divided by 5 is going to be 9, and 100 divided by 5 is going to be 20. So we put that with our negative, and you get -9/20ths. Number 5, complete the statement using less than, greater than, or equal to. Well, here we have both sets of questions with negatives. So the first idea that you need to remember is negative is like I owe. And you don't want to owe money. So the less you owe is actually the better. We can't compare fractions unless we have the same denominator. So using the song LCD, first thing you got to check if 1 goes into the other. So you're looking if 4 goes into 8. And it does. So the -2 and 5/8 can stay. But now the negative 2 3/4 is going to have to be multiplied by a factor of 2, and it becomes 6/8. Now 6 is greater than 5, so you don't want to owe a bigger amount. This is the greater absolute value, but you want to owe the smaller negative. So the smaller negative actually wins. So the symbol will be a greater than. Negative 2 5/8 is greater than negative 2 3/4. Same idea with number 6. Let's change this to money. This is I owe $6.40. This is I owe $6.30. Better to owe a dime less. Okay, number 7. Your skateboard ramp is 2 5/8 feet high. Your friend's skateboard ramp is 2 3/5 feet high. Which skateboard ramp is higher? So that's the question. We want to know which skateboard ramp is higher. So we need to compare 2 5/8 versus 2 3/5. Well, the 2 part is the same for both. But we can't compare the fraction part unless we have a least common denominator. Between 8 and 5, if you check, 5 will not go into 8, so you need to use the multiples. So you're thinking of the first number that both 5 and 8 will go into, and it will be 40. So you're going to convert them both to be something over 40. The 2's stay. So 8 times 5 is 40, so 5 times 5 is 25. 5 times 8 is 40, so 3 times 8 is 24. And you can see that this one, the 5/8 fraction, is worth more than the 3/5. The 5/8 belongs to you. So you'd say, my ramp, which was the 2 5/8 feet. My ramp, 2 5/8 feet. Okay. Next, add or subtract. Write fractions in simplest form. So only if it was a fraction do you change it to a fraction in simplest form. You don't change the decimals to fractions, you leave them as decimals. So the first thing that I know that I'm going to do for all of these is circle, label, choose, use. Now you know that we had the activity in class where everyone got to practice and share how good you all are at doing these type of problems with whole numbers. So you're getting them right, you understand the concept with whole numbers, now you just need to add the layer of whether it's decimals or fractions and follow the appropriate steps. So starting off with number 8, you know that 5.98 is a positive term, and subtracting a negative 3.56 is also a positive term. Taking away a bad thing is good. So the rule here is going to be same, add, keep. So you're going to add these two. In order to add two fractions, you're going to line up the decimals. So I'm going to make a decimal line right here. .54. Now, I know that's my answer. I'm going to bring down the positive sign to remember that I keep the sign. I just bring down whichever one is closer. So number 8 is positive 9.54. Doesn't have to have the positive sign, but that way we know that you know. Number 9, this is a negative 5/3. And this is a plus 1/3. So this is going to be different, subtract, bigger. So I'm going to subtract 5 minus 1 and I get 4. Still the same denominator, 4/3, because we had the common denominator from the get-go. Now I need to find the bigger absolute value. So remember, we're not looking at whether it has a sign, we're thinking of absolute value, the distance from 0 that the number is. So the negative 5/3 is greater than the 1/3 if you're just looking at the absolute value. 5/3 is a greater value than 1/3. So you take the sign above the 5/3, which is negative, and do a sign trail. So your final answer is negative 4/3. If you feel like putting it in simplest form, that is a good simple form. It's reduced, everything is good, But if you feel like converting it to be 1 1/3, as long as you remember your negative, that's just great also. So number 9 is -4/3 or -1 1/3. Number 10, same idea. You've got 4 2/5, which is a positive term, and subtracting a -6 1/4. That's also taking away a bad thing, just like it was with the decimals, same thing. So this is going to be same add keep. So we're going to add these two together. They do not have a common denominator, but they're going to add, so I know I don't have to borrow. So I'm going to set these up right here. 6 1/4 and 4 2/5, and I'm going to put what they equal when I'm adding them. Well, 4 and 5, the LCD is going to be 20. I think 4 goes into 20 how many times? 5 times. So 1 times 5 is 5. 5 goes into 20 4 times. 4 times 2 is 8. And that's called the conversion. We just converted 1/4 to be 5/20. Keep the 6 the same. Convert 2/5 to 8/20. Keep the 4 the same. Now I can add like with like. So the two whole numbers, 6 plus 4 is 10. The two numerators, 5 plus 8 is 13. And the denominator always stays the same. It's just the size of the piece. Now, is that going to be a positive or a negative 10 13/20? Well, both of the signs above were positive, so I can just do my little sign trail, and it's a positive 10 13/20. We know that if you don't put the positive sign, it still is positive 10 13/20, but that just shows your clarity and that you absolutely know what you're talking about. Okay, so this is positive 10 and 13 over 20. Okay, number 11. Same idea, circle, label, choose, use. This is negative, and this is negative. So now we have same add keep, but with two negatives. So we're going to remember to keep the negative. So we're going to add these. Again, we line up the decimals, 9.24, 2.19, adding together, 11.43, but again, we've got to keep the negative, negative 11. Oops, sorry, you couldn't see that. So I added 9.24 plus 2.19, lining up the decimals, and I got 11.43, and then I remembered to keep the negative. So it's going to be negative 11.43. Now the next two are really easy, but some students got really confused by these extra lines. So I'm going to mark, this is 1, this is 2, this is 3. So it's going to be 3, and then this is a half, and that's a half, so a half and a half equals 4, and then you've got a little bit more, 0.4. So that's one way you could just estimate to see how much it's going to be. But also to find the distance between, you could find the distance from 0 to negative 2.5 is 2.5. And then the distance from 0 to 1.9 is 1.9. So if you add 2.5 plus 1.9, you'll get 4.44. I'm sorry, 4.4. It's always going to be positive because it's a distance. Same thing here, if you go from 6 and subtract 3 1/2, well, this is going to equal 5 and 2 over 2. You're going to subtract and see it equals 2 1/2. Another way to see it is this is 1, this is 2 1/2. 2 1/2. So here, this is 4.4, and this is 2 1/2, or 2.5. Okay, that's it for the front side. We'll have a new video for the next side.